So this little video is just going through the PowerPoint presentation that we're using in algebra called Collecting Like Terms. So what are terms? A term is an expression that can be separated into terms that are joined together by positive or negative signs or addition or subtraction signs. In the expression 5a plus 3b, the terms are 5a and 3b. The like terms are made from the same letters. For example, 2a and 3a are like terms. 5a and 3b are not like terms because they have two different variables. You can simplify expressions just by collecting the like terms, and to collect like terms we either add or subtract them. Let's have a look at this little activity here. So we have a cups and counters activity. You can see that our cups have variables, so we have x and an x. And the reason we've used cups to symbolize them is because that can be any value. So the cup can hold any value for x. In this particular case, I have 1, 2, 3 x's, and then I have this series of dots here. That's a constant. There's only ever going to be that many dots. So let's have a look at how that's been rewritten. If I look at the picture, I can see that I have my x plus this x plus this constant plus this x. And down the bottom here, I can see I have this x corresponds to this one. This x corresponds to this one. My 4 corresponds to these dots. And lucky last, this x corresponds there. So that's how we found this equation, x plus 4 plus x. We want to simplify that though, because as mathematicians, we don't want to have a really big, long equation if we can help it. So what we're going to do is we're going to think about what we have. We have our x at the front here. We have a plus x here. We have another plus x here. And we have a plus 4 here in the middle. With this x at the front, it doesn't have a sign out the front. So we're going to infer or imply that this is a plus x. And that's important as you move through algebra. So let's rearrange this. Let's rearrange this to equal, I'm going to put all the x's together. I've got my first plus x that tells me where I'm starting. That's that one there. Then I've got my second plus x. And then I have my third plus x. So I put all the x's together. And now I'm going to put my constants together, plus 4. So the next thing I'm going to do is I'm actually going to look at these and see how many x's I have. I have 1 plus another one is 2 plus another one is 3. That gives me 3 x's. And then over here I have my plus 4. So I've collected my like terms, which were my x's, and turned them into my 3x. And then I've collected all the constants that I have, which is just that plus 4, and put that one there. So that's how I collect my like terms and I simplify my equation. Let's have a look at our next one. So this one I can see I have two different types of variables. I have a y plus a y plus an x plus this constant here plus another y plus a constant plus an x. So let's rewrite this one where I'm just going to write out exactly what I see. I'm going to write it in black up the top. So I have y plus x plus, now this one here has 2 dots, so it's a 2, plus y plus, I've got 1, 2, 3, 4 dots this time, plus my last one is an x. So now that I've written out all of the components or parts of the equation, I'm going to look at grouping my like terms. So I'm going to choose a green colour to highlight my y values. So here's my first y value here. Here's my second y value here. My x isn't a y, the 2 is not a y. Here's my third y value here. I've got a 4 and an x, so there's no more y values. I'm going to use a blue colour to circle my x values, so I can see I have an x value here. This one here is a constant, this one's a constant, and then I have my x value there. And then lucky last, I'm going to use yellow to circle my constants. So that's a constant, and I can add that to my other constant. So I'm going to rewrite this equation here where I group all the same things together. I'm going to do it at the bottom here. So if I start with my y's, I have, now my first y here, I need what type of sign it is. And I know that if there's no sign out the front, then it must be a plus. And that's important because that tells me what direction I'm going in. So let's write this out. I have a plus y. So that's my first one. My second one is a plus y. Looking for anything else that's coloured in green. Here we go. I have another one here, plus y, and I can't see any more y's. So I'm going to go for my blues. I have my x variable here, so that's a plus x. And here's another x over here, plus x. And then lucky last, I'm going to do my constants. So that's my yellow bubbles. There's a plus 2 and a plus 4. So this time I can simplify this even more. I can add these together because they are all the same variable. I can add these together because they are the same variable. And I can add these together because they are constants. So let's add each of these together. I'm looking at the y's in the red bubble. I have 1y, 2 y's, 3 y's. So there's a 3 and a y because I have 3 lots of y. Then I'm going to put a plus in. Let's just check. I've got looking at my x's, I've got 1x and I add another x, so that's 2 x's. It's a positive 2x because I have a plus and a plus. So if I have plus 1 and add another one, that's plus 2. And then lucky last, I have my constants. So I have 2. If I start at 2 and I add 4 more, I get 6. So my final equation for this one is 3y plus 2x plus 6. In this example, we can see that we have this equation here. A plus A plus A plus A plus A. In this case, we do just add up all the A's. So if I start at 1A, I have 1A, 2A's, 3A's, 4A's, 5A's. And it is just as simple as writing 5A. 5 lots of A is the same as saying 5A. In this example, we're going to simplify 4y plus 5y, take 2y. So let's have a look at our little bubbles with that one. So with my 4y, I'm implying a plus there. Then I have my plus 5y, but then I'm going to take away 2y. So if I read the instructions here, it says just combine the terms. Don't forget that there is a negative before the 2y. So let's have a look. I'm going to rewrite this here. I have 4y plus 5y, take 2y. Now because I'm doing bombas, that means I can do this part first before I do this part. So I'm going to step it out a bit. 4y plus 5y is 9y. Take 2y. And if I had 9 y's and I took away 2 y's, I'm going to have 7 y's. Let's prove it though. So I'm going to draw 9 y's over here. I now want to take away 2 of those y's, and what I'm going to do is I'm actually going to cross them out. So take away 2 y's, 1, 2. So let's see how many y's I now have. 1, 2, 3, 4, 5, 6, 7. So indeed, 9y take away 2y is 7y. In example 3, we can see we've got a flow chart. So let's just talk through it. It says up the top here, if you have a mixture of different terms, it's a bit trickier. To simplify expressions like this, you must still only collect like terms. So if we have a look at this one, I've got some x's. There's an x and an x. And I've got some constants. And notice that I'm circling the operation in front of them, the plus or the minus. So step 1 says, put circles around each term, just make sure that the plus and the minus sign is in front of each one. And we can see that there. Step 2, combine the like terms. So we can see here that we are going to have, I'm going to write up the top here, 2x. I'm going to use that one. I now want to put the same term. I'm just going to write it beside it so that my brain remembers. I've done that one. Take away 5 plus 6. So now that I've done that, I can then combine this part together because they're like terms, and I can combine this part together. So I'm going to put an equal sign, and I'm going to make sure I balance that equation. So let's do this first part here. 2x plus 5x. If I have 2 x's, 1, 2x, there's my 2x, and I add another 5 x's. Here is my 2 x's. Here is my 5 x's. I can count that up to show how many x's I have. I should have 1, 2, 3, 4, 5, 6, 7. 7 x's. So I know that this part here is equal to 7x. Okay, now we're going to have a look at our next part in blue. It says I'm going to start at minus 5 and I'm going to go up 6. So if I have my number line, starting at negative 5 and go up 6. 1, 2, 3, 4, 5, 6. I land at 1 and it's a positive 1. So I put plus 1. So let's see. Let's have a look down here at the components that are here. So if I look at this box, I can see that we have 2x plus 5 equals 7x. That's the same as what we've got here. And in the second part, we have negative 5 plus 6 equals 1. And that's what we calculated there. Remember, if there is no sign in front of the term, then we use a positive or a plus. So our final answer becomes 7x plus 1. Yay for us. In this next section, I'm going to go through the solutions for each of these and the thinking that goes with it. Every single time I'm going to rewrite the equation and I'm going to look at grouping like terms. So in question number 1, we have an equation that says a plus a plus a plus a. First thing I do is I write the equation. I'm then going to put an equals here for this one. Let's see. I know that this is a positive a out the front, and then I have all of these other positive a's. So that 1, 2, 3, 4. I can see 4 there. A plus a plus a plus a. There are 4 of them, so there must be 4 lots of a. 4 a's. In the second question, I'm going to rewrite the question again. 2 b's plus 7 b's plus 4 b's. Now because these are all b's, then I can just add these numbers together and keep the b at the back. So I have 2 plus 7 is 9 plus 4 is 13, but I must keep the b, 13 times b. Now of course the real question is, prove it. So let me do this the really long way. So I'm going to make my 2 b's look like this. B plus b, that's my 2 b's. I'm going to make my 7 b's look like this one. So that's my 7 b's. And I'm going to make my 4 b's look like this. And now, doing this the very inefficient way, I'm actually going to count up and make sure I have 13 B's. Let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 B's. Now this method is only going to work because all of these are positives, so they're all going to add up. I need to be really careful about these signs, and if there are any negatives in there, then I need to actually factor that negative in. Our next question, again, has all of the same variable, but it does have this tricky negative. So let's write it out this time and have a look. I have 5x's plus 7x's, take away 2x's. Because they are all x's, I can just add my 5 plus 7, take away 2. 5 plus 7 is 12. So I have 12x's, take away 2x's. And 12x, take away 2x, or 12 take away 2, is going to be 10x. But again, I need to prove this to myself and make sure I haven't made a mistake. So I'm going to write out my x's again. So I have 5x's. I have 7x's. And for this one, it says I'm going to take away 2. So rather than adding on 2, I'm actually going to take them away. So to do that, I'm actually going to cross out 2. So 1, 2. So I've got my 5 plus my 7, and I've taken away 2. So let's count off and see how many I now have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Woohoo! Yay, Christmas. In our next question, we can see again that we have the same variables and we have another negative. Let's write it out. So I know when I'm doing my order of operations, I'm going to do addition and subtraction from left to right. So I'll do this part first, and then I'll do this part. So let's say 6y plus 4y is 10y, because our y's are the same. Take 5y. And I know that 10y take 5y is 5y. If you want to, you can actually go through and write out your x's and check it, but I'm pretty confident with this one. Our next one, 4x, take 2x, plus 3x. Using my order of operations, I'm going to do this part first, and then this part. Put my equal sign down. If I have 4x's and I take away 2x's, I have 2x's, and then I add my 3. 2x's plus 3x's is 5x's. Let's check it. So my 4's I'm going to do blue. Now, so that's my 4. This next one is my take 2. So let's take 2. 1, 2. And then I'm going to add my 3. So that will give me 1, 2, 3, 4, 5. 5 x's. Our next one. More of the same, really. 2 lots of n plus 3 lots of n, take away 4 lots of n, or 2n plus 3n, take 4n. Order of operations mean I do this part first. 2 plus 3 is 5n, take 4n. 5n take 4n is just n by itself. Now I could write 1n, but in algebra we don't bother with the extra writing, because 1 times any number is just a number, and it's the same with algebra. 1 times n is just n. Here's our next one. This looks very interesting. So when I see this one, I'm thinking about what these mean. Now with this one, I actually think there's a typo. I think this is supposed to be x squared plus 3x squared take 2x squared. So with this one, my variable is actually this part here. That's my variable. So I can treat that just like I would any other variable, like an x or a t. So I am just looking for my coefficients. So there's a coefficient there, and there's a coefficient there, and there's a secret coefficient here. So I know it's going to be a positive for my coefficient at the front, and if there's no coefficient stated in front of my variable, then my coefficient is 1. So let's have a look at my equation now. So I'm going to just, in my mind, think that this is going to be 1x squared, even though I don't need to write the 1x squared, but this is just helping me while I'm learning, plus 3x squared, take away 2x squared. So I'm doing this number, and this number, and this number, and I'm going to keep this as my variable at the end because that's for every single term there. So if I have 1 plus 3 is 4, 4 take 2 is 2, so I'll have 2 as my coefficient, and x squared is my variable. Don't be scared of these ones. They're friendly. Lucky last one for this list is this one here. I can see I have the same variable for each, so these can all go together. So I'm going to rewrite this as 6c take 5c plus 2c. Order of operations mean I have to do this part first. 6c take 5c is c by itself. If it helps just for the time being, you can write 1c, but we're not going to write 1c very often. C plus 2c is 3c. Let's have a go at these ones. So the first thing we're looking for here is, do they have the same variable? I have 3a, oh, I have 6b there, I have 2a's there. So my a's can be added together, but my b can only be added to b's. So let's rewrite this one with the a's grouped together and the b's separate. So I have a plus 3a because there's nothing out the front of that one. So 3a plus 2a because I've put my a's together, plus, now I'm going to put my 6b in there. And I have a plus there, so it's a plus 6b. Now let's just group them together. How many a's do I have all together? And how many b's do I have? 3a's plus 2a's is 5a's plus 6b. So that's my answer for that one. Question 2. I have y's, a 9y, and a 9y. I have some p's. So the first thing I'm going to do is rewrite that with the y's grouped together and the p's together. Notice at the front here, my plus 9y. That tells me where I'm starting. So I've got 9y, that's that one, plus 9y. And all I'm doing is copying it down. Now let's look at our p's. Plus 8p minus 3p. So let's add these together. So I can add these two together because they both have y's in them. And then I can, well, I'm not adding them together, but I can put those together as well. So let's do our 9's first. So, our y's first. So 9 plus 9 is 18y. Before I work out what my operation is here, I'm going to do this calculation first. So if I have 8 p's and I take away 3 p's, 8 take away 3 is 5. So I'm going to have 5 p's. And I know it's a positive 5 because I'm starting at 8, positive 8, and I'm taking away 3, so that gives me positive 5. And that's why I have 18y plus 5p for my answer for that one. Let's look at this one. I have, let's circle our k's first. I have 8k, I have a u, and I have a negative 5k there. With my u's, I have a positive 3u and a positive 5u. So my first step is to rewrite my equation putting my k's together, and I'm going to make sure that my 8k is a plus. So I start at 8k, and then I'm going to take away 5k. I'm now looking at my u's. I've got plus 3u plus 5u. So now I'm going to calculate this one, and then I'm going to calculate this one here, and notice I kept that little plus sign as part of my calculations. Putting my equal sign in here, let's do our k's first. So if I start at 8 and I take away 5, I get 3, and I keep my variable there as k. I haven't thought about what sign I'm going to have in here yet because I need to do this calculation. If I have 3 u's and I add 5 more u's, that means I have 3 plus 5 is 8 u's. And it's a positive because I started at a positive 3 and I added on 5 more. So that's why I get a positive there. So my answer to this one is 3k plus 8u. And you notice there's no simple answer. We've just simplified the expression to make it easy to calculate. Let's look at this one. Again, I have s's, so let's put a circle around this one and a circle around this one. And I have q's. Let's rewrite it with our positive 7s at the start. So I'll start with this one here. 7s, I'm going to put a little positive there to remind myself. Take away 5s plus 4q plus 3q. So now that I've rearranged it, I'm going to see if I can simplify my s's and then simplify my q's, making sure I've lassoed around that positive in front of the 4. So looking at our s's, I have 7 s's, but I take away 5 of them. Okay, I need to draw a picture for this one because my brain's not thinking too good. So I'm going to draw my 7 s's. 7, so that's my 7 s's. Now I want to take away 5. So I'm going to take away 5 of them. 1, 2, 3, 4, 5. And that leaves me just with my 2 s's. So I have 2 s's there. Now I'm going to look at my q's. I'm going to start with my 4 q's, and it's a positive 4 q's, and I'm going to add 3 more. So 4 plus 3 is 7. And 7, if I start at a positive 4 and add 3 more, it's definitely a positive 7. Don't forget to write my q on the end. So for this equation here, my answer is, or my simplification is 2s plus 7q. Our next question. Again, we're going to circle our like terms in the same colour. So I'm going to choose yellow for my x's this time. There's an x. There's an x. I'm just going to put a little plus in front of this x here to remind me. I'm going to use green for my y's. And then I'm going to rewrite my equation so that my x's are together and my y's are together. So I have, let's write it down here so it's easier to see. So plus x is that one, plus 4x, take y, plus 4y. And I'm going to work out that one first, and I'll work out this one second. Put my equals. Now the trick here is to remember that just an x by itself actually has a 1 in front of it. So I really have 1 plus 4, which is 5x. Makes it nice and easy. I'm not sure what the operation is here yet because I need to calculate this one. If you're not sure, you can always draw a number line. So let me do that. It's late. So it wants me to start here at negative y. So that means I need on my number line. Now the trick is, where is negative y on my number line? So remember that if there's no number in front of the y, then we know it's a 1 because we don't bother writing 1. It's an invisible maths. Not only is this one an invisible one, but remember we also have a negative in front of it. So this is time I'm going to start at negative 1 and I'm going to jump forward 4 spaces. 1, 2, 3, 4. So my answer is positive 3y. So I can have a positive for my positive, 3 for my number that I landed on my number line, and the y is the variable that we were working out. So when I simplify this expression, I get 5x plus 3y. Our next question, more of the same really, isn't it? I'm going to start by circling my D components. Notice I'm taking the operation in front of it. With my first operation, because there's nothing there, I'm going to count that as a plus or a positive. And then I've got this little lonely s by itself. Let's rewrite it. So there we go. I've rewritten my 5d plus 5d take 7d. And then on the end, I've added my plus s. So the first part I want to calculate or simplify is that part there. And look at that little s at the end that doesn't need any simplification. So put my equals. I'm going to bounce along. If I have 5 and I add 5 more, I must have 10. 10 take away 7 is 3. So that means I have 3 d's plus my s at the end. Almost there. Here's one for us, this one here. So I can see I have A's and B's and C's this time. We can do this. We just need to be methodical. So I'm going to get rid of that one there. I'm going to start by putting my secret plus in front of my 2A. And then I'm going to circle all of my parts that have A's in them. And remember that I'm taking the sign with me. Okay, I can't see any more A's there, so I'm going to choose a different colour, and now I'm going to circle my B's. There's a B there and a B there. And lucky last, I'm going to circle the C's. And that just helps me organise my thinking. My next step is I'm actually going to rewrite the equation so that my A's are together, my B's are together, and my C's are together. So I have plus 2A, that's that one, plus 5A, that's that one. Don't have any more A's, so now I'm going to go on to my B's, plus 3B, there's that one, take 4B, there's that one, minus 3C, plus 5C. Thank heavens I have enough room on my monitor. So now I'm just putting a little box around each of those things that I can calculate together. And I'll start with this one. So I have 2 A's and I add 5 more A's. 2 plus 5 is 7. So I must have 7 A's or 7 lots of A. Let's look at our next box. I'm starting with 3 B's, but I'm taking away 4 B's. Now, if I start at 3 and take away 4, that means I must be getting into some negative number territory. So in this one here, I'm starting at 3B, and it's a positive, so I'm starting here, and I'm taking away 4. 1, 2, 3, 4. So I will have negative 1b. And I'm going to leave that for a second. I'm going to go back and change that. So this one here in my green box is negative 1b. Ugly. I'll change it in a second. Let's have a look at our next one here. That says minus 3c plus 5c. So if I start at minus 3c and I add 5 more on, 1, 2, 3, 4, 5, I'm going to land here at 2. So that's a positive 2c, because remember I'm using c's. So that's really quite good at the moment. My only problem is I don't like this one here. I don't like having a 1b. So we know in algebra, if there's a 1, we don't have to write it because it's implied, but I do need to keep this negative. So 7a minus b plus 2c. So if you got to this part here, that's really, really good. You just need to learn how to use your invisible maths to get it to here. Okay, our lucky last one for this session. I'm going to look at my x at the front. It doesn't have anything in front of it, so it must be a positive. I'm going to circle my x's in blue. There's an x there. There's an x there. Whoa, there's z's there. Can you do that? Of course you can. I'm going to look for my y's next. There's a y there, no more y's. And then I have my z's here. A negative z and another negative z. So let's rewrite it. I'll go back up here. I have positive x, that's that one there, plus 3x, plus 2y, minus z, minus 4z. So we're going to calculate our x's first, and then going to calculate our y's, and then we'll calculate our z's. So there's the 3 ways I'm going to do it. So I put my equals in. So let's look at our x's. I have, there's no number in the front here. If there's no number in the front, then we apply that it's a 1. 1 plus 3 is 4. So there are 4 x's. Let's have a look at our y's. There's actually nothing else to add here, so I can just put in plus 2y. And then finally, let's have a look at this one here. Minus z minus 4z. Now this one here tells me on a number line I'm going to start at minus z and then take away another 4z. I'm going to draw a number line again. Now the reason I haven't actually gone up this way for my number line is because if I'm starting here, which is here, and then I'm going in that direction, another 4, there's no point in going back that way. So I've started here. I've started here on my minus 1, because remember I've got a secret 1 in there because it's an invisible maths, and it's a minus 1. And I'm going to then take away another 4. 1, 2, 3, 4. And that bounces me here to negative 5. So my operation is negative 5z. So this one here is a bit tricky because not only are they making us think about this, but they're also making us think that negative z is the same as saying negative 1z. And that told us where to start on our number line. I love a good challenge. Okay, for each of the shapes, write the perimeter as a simplified expression. We've done these before. And all measurements are given in centimetres. So let's see. We want perimeter. So I need to understand what perimeter means. Perimeter is the distance around the outside of a shape. So if we do the distance around the outside of a shape, that means we must be adding this one plus this one plus this one plus this one. So let's give it a go and see what we see. So my perimeter, I'm just going to use P for perimeter. So perimeter equals this one, which is an x, plus this one, plus this one, plus this one. I've seen this before. Let's see. I have 1, 2, 3, 4 x's. So my answer must be 4x. Let's look at our next one. So again, perimeter is the distance around the outside. So we're going to have this edge plus this edge plus this edge plus this edge. So let's write that one out. I've got P equals, let's start with this one up the top, 2x plus 5 plus 2x plus this distance out here, which is the same as that one there, 2x plus 5 plus this distance here, which is the same as that one. Now I can add them all up. I'm going to add my x's. Oh, almost forgot to take the plus for that one. There's one little pluses there. That's the plus there, and that plus there. So those are all my x's. And I have my whole numbers there. So 2x, that's that one, plus 2x, plus 2x, plus 2x. Now I'm adding my whole numbers, plus 5, plus 5. Can you count in twos? Let's go. 2, 4, 6, 8. So I have 8 x's, and I have 5 plus 5 is 10. Here's another way you could do this though. Because we know that this area is going to be this plus this times 2, we could actually just multiply it all by 2 using the distributive law. More than happy that if you've done it this way, and I'll show you how to do it the other way. So we know that the perimeter is going to be 2 times 2x plus 5, which is this one at the top here, plus 2x. So I'm going to simplify that, keep this out the front here. We're going to work on this part in here. So I have 2 x's, and I add another 2x, which is 4x. And I have my plus 5 just there. So now here's when the real magic begins. So to do this, I'm going to keep my 2 there. I'm going to keep my times there. I just want enough space to breathe for this one. I'm just copying out that last line. I'm going to say 2 times 4x is just 2 times 4 with the x written after it. So 2 times 4 is 8x. And 2 times 5, and it's a positive 5, 2 times 5 is 10. Much quicker, but it's a learned trick. Okay, our last one is a triangle. Again, it's perimeter, so we want the side plus the side plus the side. Let's go through and add this one up. So we need to write it out. We have our first side here is like P equals 5x take 3 plus our side here, which is 2x, and then this side here, which is the same as that one, we can tell by the markings on the triangle, which is a plus 5x take 3. So let's circle our common variables. Now let's rewrite it with those together. Now let's simplify that one, and we'll simplify this one. So I have 5x's, 5 plus 2x's is 7x's, plus another 5x's is 12x's. My next one, if I start at -3 and take another 3 away, where am I? So this one here is telling me that I'm starting at -3. So start at -3, and then we're going to take 3 away. 1, 2, 3. That lands me on -6. So this calculation here, -3, take away 3, lands me on -6. Take 6.